One, three, two, one. Okay, so it's been a while. Uh, we had some ups and downs, but we moved. We have been grinding, but but with not that, with not that much, gut and grit. But we'll continue. Uh, was not a setback. So we'll start with strings. First question is largest odd number in a string. Uh, Largest odd number in a string means the not a digit. It cannot be a digit. For example, if the string is given as 5347, then the output will also be 5347. And if the output is 0024, the output will be nothing, an empty string, because you have to take a substring um, which is of odd number in it itself, and it cannot have leading zeros. So now, for example, if the string is 203148 now here we do not want the leading zeros, and we want the largest number. Now here we will work greedily. We will work from behind, because if we work from the most element, we will try to cut it down from the last. So what makes a odd number a odd number? The last digit of that number should be a odd digit. So we will go back of the array uh, to the first odd number, odd digit. Like in this example, 002031483438. Sorry, here the last digit is 8. It's an even digit, and after that comes the 3. So we will make a j pointer at 3, and we'll move from the front, skip all leading zeros, and have a I pointer at the first non-zero element or non-zero digit. So the substring from I to j will give us the largest odd number in the string. Here, it might be possible that there is never a odd digit from the right. So we will will iterate from length minus 1 to 0. Then if the uh, character at I in the string s minus 0 to take it out, mod 2 is 1, and we assign index variable to I, and then we break out. Then if the iteration completes and the index is never updated, it's still minus 1, then return a empty string. Then we'll move to the second task, which is removing the leading zeros. Now we'll also take a pointer I, for now 0, while I does not pass this last odd number, and the the I is 0, we'll continue to move I. So what will happen is I will become the first non-zero element with this logic, and then we can return the substring s dot substring I to j plus 1, because in Java the substring is exclusive of the ending index. Now second question is reverse every word in a string. Now sentence is given to us, for example, welcome to the jungle. Now the output will be jungle to the welcome, right? So what we are doing, we are placing them in the opposite order. And there is also a constraint that if there are leading zeros, trail zeros, or extra zeros in between the words, then we also have to remove them. There will only be one between the words in our output. So, for example, the string is given to us is blank 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 hello blank 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 Raj blank blank Vikram blank blank. So you can see there are extra zeros, leading zeros, and trailing zeros. Vikram blank Raj blank hello. So what we'll do is we have to first find the first character of the word. So in our example, that would be hello ka H, the first character, and then we have to put that word in the list. So what we will do is while I is less than n, which is the outer loop, because we have to do these three tasks over and over again for all the words in the sentence. While I is less than n and s dot caret I is blank, we'll move I. Same as we heard what we have done for removing leading zeros to go to the first character. Then, if at any point of time I is greater than or equal to n, we break out. What that happens when there are all blanks left, then we break out. Okay. Then if not, we make a start pointer at I, and then we what we have to do, we have to find the last character. Then I is less than n, and s dot caret I is not a blank. First we wanted a blank till blank, the next element is blank, and then we wanted next element to not a blank. So here the I will be what? Here the I will be our end plus one. So n will be I minus one. So we got a starting and the ending of a substring. Now we will just add list dot add s dot substring start comma n plus one. Now this will continue to happen and it will establish the first sentence in the list. Now we'll take a string builder s or answer or anything. Then we will iterate the from the last or the end of the list to the first, which is list dot size minus one. Then we will do answer dot append list dot get dot j, which is iterating from back to front. Then if any point of time j becomes 0, we'll not add the blank in between. So otherwise we'll add a blank. So it's one time happening case in the if statement. So if j not equal to 0, then answer dot append blank, because when it becomes 0, when it comes at the last word, then we will not add a blank after the word. So then you will return the answer. The more optimal approach can be we reverse the whole string, then we reverse every word in the string. Now we know how to get the first and last character and do that. But here, what will happen is uh, once leading zeros and trailing zeros and extra zeros between the words will not be uh, taken out. So what we'll do, we will left shift all the characters word by word, leaving spaces in between Now there is longest common prefix. For example, a string of an array of string is given to us, which, for example, here is flowers, flow, fly, and flight. So here the output will be FL. If the string is less than the prefix, we'll return an empty string. So first, we will answer the brute force method, where we pick up F from the first word here, which is flowers. Then check if all other words have that F in the first position. Now we'll pick up the second character, which is L in flowers. Then we'll check if FL is there in all other strings. Then store FL. Now we will check FLO, but it's not there in flight. So here we can stop. But this is not an optimal solution. So what we do is the array of strings lexicographically. Lexicographically meaning like they would be placed or positioned in a dictionary. So after sorting them, the array will be like flight, float, flow, and flowers. Flight because FL is common there everywhere. Then I comes before float, then flow. Why float first? Because after FLO there is A, and then in flow after FLO there is W. A comes before W. Now after flow there is flowers because the smaller substring will come first. So therefore the string array will be flight, float, flow, and flowers. Now we will pick up the first and the last element, last word, and do comparisons between them and get how much similar they are. Uh, and but because you are picking it and you have sorted it lexicographically, the how much they are equally they have the common prefix, it will be true for all of them in between. So now the first and last element will be flight. We will compare all the indices from I pointers, I, and we'll move it. Okay. So we'll compare 0, 0, which is FF, it's right. Then LL, it's right. I and O, it's not right. So the indices 0 and 1 will be arrays dot sort V, string builder ANS. String first will be v of 0, string second will be v of v dot length minus 1. Then we'll iterate the array from the length 0 to minimum of the length of the first and last element. If they do not match, if first dot caret I is not equal to second dot caret I, then we just return the ans dot to string. Otherwise, if it is matching, we'll just append in the ANS. ANS dot append first char, or you can do the second one also. First dot char at I. Then after the iteration is complete, we can just here. What is important to understand, which I have not done previously, I will go back and do it. The time complexity which is taking. The time complexity here for the sorting part will be n into m into log n, because normally sorting takes n log n. Comparing two strings during uh, this costs up to O of m, and then again the iteration takes O of m. So the O of m, the second one is dominated, and the time complexity becomes n into log n. And previously, I have not discussed time complexity. For the largest odd number in a string, the we are iterating once. So the time complexity will be O of n, and then reverse every word in a string, the time complexity O of n again, and the space complexity O of n. But the time complexity in the reverse every word in a string will be O of 2n, because we are iterating twice, but O of 2n equal to O of n, same thing. Then there comes valid anagrams. Now we are given two strings s and t. Return true if t is an anagram of s. What is an anagram? Anagram is a word found by rearranging the letters of another word. Now, for example, S is anagram, ANAGRAM, and T is Nagaram, NAGARAM. So the output is true. And another example we can is S is dog, DOG, and T is cat, CAT. Now, one brute force solution what we can have is we will sort both of them. For example, S is eat and T is tea. So what we'll have after sorting, AET and equal if they're anagram. So the optimal approach will be using hashing or counting, where we will take a hash array of size 26 represent, and each element representing ABC alphabets of the letters. Now, for one of them, we will increase the frequency, and for the other of them, we'll decrease the frequency by one each time. Then for EAT, at indices 0, 4, and 19, 1 1 will be and then we will iterate on the t, and then one will reduce at 0, 4, and 19 indices. And if it is genuinely an anagram, the whole array will still be 0. So we'll use that. And also there is a base case, edge case, whatever, that if t and t's length are not equal, then it's obviously not an anagram. So we will make a hash array. Then when iterate on the character s dot to character array, hash of character minus a is plus plus. So what will happen is whatever the character is, if there is it, so e minus a. Now a is 97, e is something that will reduce, and it will increase. Add that index, because if it would be a minus a, then it would be zero. So you got it now. Then if any time I is 0, then we will turn false, and if the iteration is complete, it is anagram written. Then rotate string. Now we don't just have to rotate a string. We are given two strings s and goal. We have to return true if s can become goal after some rotations. Rotation is shifting the strings left in a circular manner. For example, S is given to us A, B, C, D, E, and the goal is given C, D, E, A, B. Now, here the output is true because C, D goes to the left, and then A, B from here goes to the back. So, um, uh, so the brute force solution can be we take the right and the left, and then check it. we we will try all possible shifts and compare. Now, what can be all possible shifts? A B C D E, B C D A, C D A A B, D E A B C D, E A B C D, then again A B C D, right? So, what will be the string after the rotation will be at every time we'll add the right part, then we will concatenate the left part. Then we will move the I from 0 to n minus 1, because we will not try to. I have to check one thing. And I need to check is I guess will not check the last element, but not for sure. Here, why is it not coming? Remove. Sorry. We will check till then. Okay. And then we will make a new string rotated, which will be s dot substring I. On that I, beginning beginning means to the whole end, we'll get it. Then plus s dot substring. It's usually the right part. Then s plus substring 0 to I, where I is non-exclusive. Is equal to goal at any time. Dot equals goal. Then return true. And if the iteration is complete, return false. Right. So the optimal solution will be just there's a property concatenate S with S. So, for example, if S is A B C D E, goal is C D A A B, then S plus S in a new string SS will be C A B C D E A B C D E. So, what you can see here, C D A B lies in between. So, what we will do is equal to S plus S, and then we will return double of S dot contains goal. So now we need to understand the time complexities here. Now making a new string costs us some time complexity, which is O of n, and the for loop in the brute force also costs us for. root for solution will cost us O of n square quadratic time. And in the optimal solution, the double of s, making a new string, costs us O of n. And then dot contains function also costs us 2 of n. So O of n. So here we will get O of 2n. And no, since making it contains will be O of n, but it is double in size, so it will be O of n plus O of 2n, which is O of 3n. And says consequently O of n, because we are making a new string. Now here comes the next question, which is isomorphic string. Given us two strings s and t, check if they are isomorphic. Well, now what does isomorphic even mean? So if characters in a string S can be replaced to get T, all the occurrences of the character must be replaced while preserving the order of the character. Now, what the fuck did I just say? Now, we'll discuss some examples and we will get the gist of it. If S is given to us EGG, egg, and T is given to us ADD, so S can be mapped to A and G can be mapped to D. Now, uh, let's take one more example. There's apple and there is banana. Now, they cannot be mapped together. They are not isomorphic string because A is mapping to more than one element, fewer than one elements. So that is not possible. So let's work on our paper and title thing. So what will paper and title give? P is to T, A is to I, E is to L, R is to E. Works. Yeah, it works. Now to solve these questions using hashing, uh, we'll get two maps, S map and T map, where we will map characters in S to characters in T in S map, and then characters in T to characters in S and T map. We'll just at first initialize with three characters. In the S map, first we will do iteration on paper and title simultaneously, starting from the first, from the front. Paper ka P and title ka T. P goes to T in S map. T goes to P. Then there comes A. A goes to I in from paper to title, and then I goes to A in T map. Then similarly, P again comes. P is to T. We check if they are same. Yeah, it is. Then E N L, N N E, R N E, E N R. So the code will look like for iterating throughout the length. A and B will take S dot char add from S, or will take from T of I, and then we will check if they are not already put, because we have to check this if they are not already put, because every time we will just override and every time we will not able to be checked. So the first time we will only put the mapping for the first time. If they are zero, then we will put S of B, not just B, B plus 1, and a T map of B equal to A plus 1. Why did we do here plus 1? Because, for example, if there was no, and if not put plus 1, we will not be able to understand if we have put it or not, because initially it was 0 values. So, else if incoming S map and T map is not 0, then we'll check if it is equal to the assigned values B plus 1 or A plus 1. If it is not, we will return false. And if the iteration comes, we will return true. Now there is a simplified version of it where we will just use the scene, last scene index trick, where same map there's there will iterate. If the last scene index is not equal and return false, and we'll put uh, M1 and M2, and last index will be put there, because we only care about the last index. Because if every time we are checking the current index or last in index, and every time we are building upon the last in index, we do not care about the previous ones, right? So here space complexity will be somewhat O of 2 into 256, which is constant only. So I think I have done string questions. Array questions has also been completed. We'll come back to you. Complete some problem of the days and string questions. Yeah. So meet you next time. Peace.